Introduction to Statistics, Chapter 2, Section 2.1. Frequency distribution for qualitative data. A frequency distribution lists each category of data and the number of occurrences for each category of data. Steps to create a frequency distribution for a set of qualitative or discrete data. Step 1. Draw a table consisting of 2 columns and enough rows to include each category and a column label. Step 2. Label column 1 as category and column 2 as frequency. Step 3. List all different possible values in the category column. Step 4. Go through the data list and count the number of each value present and enter this number in the frequency column of the table. An example. Let's create a frequency distribution for the following set of data. First, if I go through, count the number of different categories. In this case, it's going to be colors. So if I look, I have red, white, blue, black, green. So it looks like I have 5 different colors. Second, draw a table. 2 columns, 6 rows, because we had 5 categories, so I need an extra row for the labels. Label the columns. So the category column will be color, and then we have the column for frequency. Next, list the colors: red, white, blue, black, green. Now, count how many in each category and place in the frequency column. Now we have to go through the data set and count how many red occurred in the data set. Well, if I go through, there's 1, 2, 3, 4, 5, 6, 7, 8. Looks like there's 8. So then I would go through, count the white, count the blue, count the black, count the green. I would end up with 5, 4, 5, 2, which is a total of 24. So this would be your frequency distribution. Now, a relative frequency distribution for qualitative data. A relative frequency is a proportion or percent of observations within a category and is found using the following formula. Relative frequency equals frequency divided by sum of all frequencies. A relative frequency distribution lists each category of data together with the relative frequency. Steps to create a relative frequency distribution for a set of qualitative or discrete data. First, create a frequency distribution table. Second, draw a table consisting of 2 columns and enough rows to include each category and a column label. Third, label column 1 as category and column 2 as relative frequency. 4, list all different possible values in the category column. Fifth, find the relative frequency for each category and enter this number in the relative frequency column of the table. So let's go back to the example we used earlier. We come up with the frequency distribution. Now we want to do the relative frequency distribution. The table looks the same, except for now instead of having frequency, we're going to have relative frequency. Now remember, relative frequency is the frequency divided by the sum of the frequency. So for red, it's going to be 8 divided by 24, and we can round that off to 3 decimal places, 0.333. White's going to be 5 divided by 24, rounded off, 0.208. Blue would be 4 divided by 24, 0.167, rounded off. All of these are rounded to 3 decimal places. Black's 5 divided by 24, green would be 2 divided by 24. So now we would have our relative frequency distribution. It's the frequency divided by the total number of frequencies. Now, frequency and relative frequency bar graphs. A bar graph is constructed by labeling each category of data on either the horizontal or vertical axis and the frequency or relative frequency of the category on the other axis. Rectangles of equal width are drawn for each category. The height or length of each rectangle represents a category's frequency or relative frequency. So let's look at the frequency distribution and relative frequency distribution we just created. So, the vertical bar graph for the frequency distribution. Well, we draw our axis, label the categories along the bottom axis. Vertical axis, we put frequency. And since our highest frequency was 8, we have to at least go as high as 8. Now next we would draw a bar above the red to go to 8, since the frequency was 8. White, the frequency was 5, so a bar goes to 5. Blue goes to 4, black goes to 5, green goes to 2. And this would be your vertical bar graph, and this would be a frequency bar graph. Now, same thing for relative frequency. You would draw your axis, label your horizontal, label your vertical axis, but this time the vertical axis would be labeled in terms of relative frequency. Now we draw our first bar for red would be 0.333, so it's a little above 0.3. White's 0.208, a little above 0.2. Blue, 0.167, about 2/3 of the way between 0.1 and 0.2. Black, a little above 0.2. Green, a little below 0.1. Now, if you take a look at both of these graphs, one's a frequency bar graph, one's the relative frequency bar graph for the same set of data. What can you tell me about the shape of the graphs? Whether it's a frequency or relative frequency, the graphs take on the same shape. Okay, examples of the horizontal bar graphs. Same two distributions, this time we're going to do it horizontally. So we draw our axis, label our vertical axis with the categories, our horizontal axis with the frequency this time. Now we draw horizontal bars. Red would go out to 8. White would go to 5, blue would go to 4, black would go to 5, green would go to 2. And we could do the same thing for a relative frequency. Relative frequency bar graph, vertical axis, again the categories. The relative frequency on the horizontal, and the red bar would go out to 0.333, which is a little above 0.3. White would go a little above 0.2 because it's 0.208. Blue would be 0.167, about 2/3 of the way between 0.1 and 0.2. Black a little above 0.2, and green would go a little less than 0.1. And again, look at the shapes of the graphs. They take on the same shape whether you're doing frequency or relative frequency. It's going to be your choice whether you use a vertical or a horizontal bar graph. Now we want to talk about Pareto charts. A Pareto chart is a bar graph whose bars are drawn in decreasing order of frequency or relative frequency. So if we look back at our frequency bar graph, the frequency Pareto chart, what do you notice is the difference? The difference is we had to interchange the black and the blue. We had to change the order because we wanted the bars to be in decreasing order of frequency. So we had to interchange the blue and the black. Same thing if you wanted to do a relative frequency Pareto chart. If you look on the left, you have the relative frequency bar graph we did earlier. On the right, we'd have to interchange the black and the blue so the bars are in decreasing order. Now, side-by-side bar graphs. A side-by-side bar graph is used to compare the data from two different groups. An example, if we did color of eyes, we surveyed male and females, and we came up with the frequency of each for brown, blue, green, hazel eyes. Now, first thing we would do is we would draw the graph with a horizontal vertical axis. The horizontal axis would be the color of eyes, the vertical axis would be the frequency, and we needed to go at least to 12 since 12 brown for the male was the highest frequency. We also put a legend. What's going to represent male, what's going to represent female. We're going to let blue be the male, green be the female. Now, if we look at brown, 12 males had brown eyes, 7 females. So we take the blue bar up to 12 and the green bar to 7. For blue eyes, 7 for male, 10 for female. So blue goes to 7, green goes to 10. Green would be 2 and 6, blue goes to 2, green goes to 6. Hazel 8, 9, blue goes to 8, green goes to 9. And this would be a side-by-side bar graph comparing males to females for color of eyes. Pie charts. A pie chart is a circle divided into sectors. Each sector represents a category of data. The area of each sector is proportional to the frequency of the category. A circle is 360 degrees. To find the angle measures of the different sectors, multiply 360 by the relative frequency of each category. Going back to the one we did earlier, relative frequency distribution for color, red, white, blue, black, green. We had these relative frequencies. Now, if I want the angle measure of the sector, I would take the relative frequency times 360. In this case, 0.333 times 360 rounds off to 120 degrees. And 0.208 times 360 would be 74.88, but for simplicity, we're just going to make it 75 degrees. And 0.167 times 360, 60.12, rounds off to 60 degrees. And then we would have 75 degrees, and the last one would be 30 degrees. So those would be the angle measures of the sector. If you were drawing the pie chart by hand, you would draw a circle and use a protractor to measure the different angle measures needed to determine the different sectors. And then you would color the different sectors in and label them. Fortunately, many programs exist to draw pie charts, and follow pie chart for our data was drawn using StatCrunch. So here would be the pie chart for our data. Now, if you look at the colors in the pie chart, I didn't have a choice of the colors. StatCrunch chose the colors for me. It'd be nicer for the red to have red instead of gold, and for white to have white instead of purple, and blue to be blue instead of red, and black to be black instead of blue. But if you did it by hand, you could use those colors. But also, every pie chart should also have a legend. Looking to the right there. Gold, red, it tells you how many there were. There were 8, and it also tells you the percentage, 33.33%. White was 5, 20.83%. Basically, if you look at this closely, the percentage is the relative frequency expressed as a percent. Now we're going to talk about section 2.1 in StatCrunch. First, let's talk about using StatCrunch to complete a frequency or relative frequency distribution of qualitative data. Okay, A, click the icon at the upper right corner of your data set and load data into StatCrunch. B, select Stat on top menu, highlight Tables, and select Frequency. C, click on the variable you wish to summarize, click the type of table you want. If you want both frequency and relative frequency, highlight Frequency, hold the Control key down, and select Relative Frequency. Then you would click Compute. Now, knowing how to use StatCrunch for this will save you time and probably increase your accuracy. I will now work through an example in my StatLab for you. Okay, here on the left is an example from my StatLab, a problem. So up here you have click on the icon to view the table of data. So if I click here, the data is loaded. Here's the table of data. If you look in the upper right corner, right up here, you have an icon. We click that icon, it says open in StatCrunch. So I open in StatCrunch, StatCrunch puts all the data into one single column. Now, one nice feature, if you click in the top space, you hit your window key and your right arrow, that will pin StatCrunch to the right, your question will be pinned to the left. Now I close the data window. Now I can see my problem and I also see my data. So if you recall, we said you would go under Stat. Once you load your data in, hit Stat, go to Tables. Then you would go to Frequency. Click on the variable. Well, we only have one column of data, which is variable 1. So I would click on variable 1. It comes over. Now, I don't need to worry about where, group by, go down to Statistics, click Frequency. If all I wanted was frequency, I would hit Compute. If I want frequency and relative frequency, I would hold the Control key down and hit relative frequency. Now you'll see that they're both highlighted. Now if I hit Compute, over here would be my table. So down there would be 12, no change would be 5, up would be 13. So now I go back over to my problem and I would type in 12, 5, and 13. Okay, now I could check my answer and excellent. Now I go on. Now it wants my relative frequency. That's why I did relative frequency and frequency at the same time, because I knew I was going to come to relative frequency. Now here's where you got to be careful. Make sure you round to the right number of decimal places. It says round to 3 decimal places as needed. So down would be 0.4. No change would be your 0.167 when you round it, and up would be 0.433. Round to 3 decimal places. And if I check my answer, I was good there. Now the next thing they want you to do is come up with the construct a frequency bar graph for these. So if I look at this, here's the frequency, 12, 5, 13. So I look at each one of the bars carefully. Well, this looks like 12, this looks like 12, and this is not 12, it's below 10. This is not 12 because it's below. So now I gotta look at the other. So it's gonna be A or B. Now if I look at B, no change, I should say, no change is 5. Which one of these looks more like 5? This or this? Well, 5 would be right here in the middle between 0 and 10. So this looks a little high. This is probably it here. So I would probably say, just looking at it, it's going to be B, by understanding what a bar graph should look like. So we're good. Now we want to go down and there's one part remaining, it says. Oh, this is for the relative frequency. They want to construct a relative frequency bar graph. If you recall, we said the frequency and relative frequency bar graphs should look the same. So now, what did we have for relative frequency? 0.4, then 0.167. So let me see 0.4. So if I go here, 0.4, that's 0.4, this is not 0.4, this is not 0.4, this is not 0.4. So there's only one of the downs is at 0.4, so it has to be A. All right, now we're going to go to a pie chart. Now, remember what I said about the legend. The legend has the percentage listed here. The percentage is basically your relative frequency written as a percent. So if you go back to your relative frequency, it's 0.4, which would be 40%, 0.167, which would be 16.7%, 0.433, which would be 43.3%. So if I go back down here, 0.4 I need 43.3 for the last one up. Well, that's not it, not it, not it. Oh, here's 43.3. There's 40, there's 16.7. So it's B. And now we got through the problem. So that would be a type of question that you could run into on the quiz. There'd be multiple parts, but it all deals with what was covered in 2.1. Now we'll go back to the PowerPoint. Now, second, talk about using StatCrunch to draw a frequency or relative frequency bar graph. As we just saw, you know, if you have a conceptual understanding of bar graphs, you will probably not need to know how to draw a bar graph using StatCrunch to answer the questions in the quiz. If you would like to know how to, a detailed set of directions are on page 6970 of the e-text. Third, using StatCrunch to draw a side-by-side bar graph. Now, if you have the conceptual understanding, any question you would run into on the quiz, you'll be able to answer just by looking at the graph. And if you wanted to know how to do it on StatCrunch, page 70 of the e-text has the directions. And finally, drawing a pie chart. Again, the understanding of the pie chart will get you through the quizzes. And if you want to know how to draw one on StatCrunch, a detailed set of directions are on page 70 of the e-text. Now this takes us through section 2.1.